Alright, today we worked on the distance formula. So the first thing we're going to do is find the distance between 2 points on a coordinate plane, and then we're going to use the distance formula to find the distance of a pair of points, or between a pair of points. So the distance formula, this is based on the Pythagorean theorem. It's a formula that is used to find the distance between any 2 points on a coordinate plane. So here's my coordinate plane, but what I want to show you, and this is what we're going to do in our first little bit, is we can take the distance right here from A to B and create a right triangle, because this distance is easy to count and that distance is easy to count. And we get to use the a squared plus b squared equals c squared if it's on a coordinate plane, and that's why it's based on the Pythagorean theorem. Or we can use this formula, which says that the distance between any 2 points with coordinates x1, y1 and x2, y2 is d equals the square root of x2 minus x1 squared plus y2 minus y1, quantity squared. So that's what's known as the distance formula. On example 1, it's going to ask us to find the distance between the points, so I'm going to show you how to do it without using the distance formula. So we're going to graph those points over 2 up 3 and back 4 up 6. And I'm going to draw a segment between the two, and then from here I'm going to use my idea about constructing a right triangle. Now, a right triangle enables us to count this distance really easily, and it's a distance of 3, and then also the distance of the base, and it's a distance of 6, and we can use this idea and the Pythagorean theorem that says 3 squared plus 6 squared equals c squared. 3 squared is 9, 6 squared is 36. We add those to get 45. We do the opposite of squaring, which is to take the square root. And the square root of 45 is 6.7. So our distance between those two is about 6.7 units. On B, we're going to use that same idea and graph those points. So over 3 up 7. I'm at the top of my graph. And the -2, -5 down 2, or sorry, back 2 down 5. And then we'll use that same idea where we construct that segment. And then I'm also going to use that to find, or to construct a right triangle, because we can count that horizontal distance and the vertical distance really easily. So our horizontal distance is 5. And our vertical distance is 12. So we'll go ahead and use that information. We'll call this side C that we don't know. We'll take our 5 squared plus 12 squared equals c squared. 5 squared is 25. 12 squared is 144. And we add those together to get 169. And then from here we do the opposite of squaring, which is to take the square root. So we get 13 for C, so our distance between those 2 points would be 13 units. Now in our next example, I'm going to ask you to actually use the distance formula. So we're going to apply that distance formula, and we're going to call this one x1, and -20 y1, -2x2, and 3y2. So our distance formula says that, let me put d in front, d equals the square root of x1, here it's 8, minus x2, and we have minus a -2, so that becomes plus 2, quantity squared, plus y1, -20, plus y2, 3 squared. So we're going to go ahead and do the math inside the parentheses under the square root. So we have a plus 2, which is 10. And I drop those parentheses, you can still keep them. And then -20 plus 3 gives us -17. And I did keep that squared with the negative, or the parentheses with the negative, because you're going to find that when we square the 100, or the 10, we get 100. And when we square the -17, you should get a positive 289. Remember that when you square a negative, it always becomes positive. So at this point, you should have no negative values under the radical or under the square root. Okay, so we go ahead and add those, and we get 389, and then we take the square root of that, which is approximately 19, and we'll go to the nearest tenth, 19.72, so it just stays 19.7. Okay, same idea on example 2. I'm going to call the first one x1, the second one y1, the first one x2, the second one y2. So d equals the square root of x1, negative 4, minus x2, 4, squared, plus y1, 2, minus y2, 17 squared. So then we take negative 4 minus 4 is a negative 8 squared, plus 2 minus 17 is negative 15 squared. And again, when you get to this point, when you square a negative, it should stay positive. So we get a positive 64 here, and negative 15 squared becomes a positive 225. Then we're going to add those to get 289. And we take the square root of 289, which is just 17. Alright, our last example, it says to determine the mileage between cities for their frequent flyer programs, some airlines superimpose a coordinate grid over the United States. The units of this grid are approximately equal to 0.0316 of a mile, so a distance of 3 units on a grid equals an actual distance of 3 times 0.316. Or 0.948 mile. Suppose the location of the two airports are at these locations, 132 and 428, and 254, 105 on the grid. It wants us to find the actual distance. So what we're going to do is we're going to call this 132x1 or 428 y1, and the 254 x2 and the 105 y2. We're going to set up our formula and take x1, 132, minus x2, 254, square that, and y1, 428, and subtract y2, 105, and square it. So we get 132 minus 254 is negative 122, and 428 minus 105 is 323. Okay, our next step would be to square them. Again, at this point, you want to make sure that you get positive values. Negative 122 squared becomes 14,884. So we get plus 104,329. So we're going to go ahead and add those, and that gives us 119,213, and then we take the square root of that, and we get about 345.27. Okay, now we're not finished because this represents the distance between the 2 points, but the units on the grid are approximately this value here. So we're going to take that number, 345.27, and multiply it by the 0.316. And that will give us about, it does say to the nearest mile, so we're going to say 109 miles. Okay, that should help you with your assignment 9-6, the distance formula. Good luck.